In PVsyst, you have the possibility to utilize the spatial layout of your system and precisely simulate the shading losses. We consider two kinds of shading losses: irradiance losses and electrical mismatch losses. Irradiance losses refer to the reduction of sunlight that reaches the solar cells. They are also called linear shading losses. Electrical mismatch losses refer to the additional losses that occur whenever irradiance is not homogeneous over all electrical components, which causes the total power to be lower than the individual maximum power point of the components. These are also called electrical shading losses. PVsyst models these in two different ways: a simplified representation in which an electrical shading factor is evaluated according to metrical partitions. This approximation is called the partition model, or also according to strings. This is a rough evaluation given an upper limit of the total shading loss, and it's especially adapted for large systems with mostly inter-row shadings. A detailed electrical calculation according to the exact positioning and interconnection of each module in the DC array. This can be done in the module layout window. In this tutorial, we'll take a closer look at the module layout. The module layout construction defines the exact position of each PV module in the 3D scene and its electrical attribution to a given string in the system. The objective of this construction is to perform a detailed electrical calculation. This calculation starts by evaluating how partial shading affects the IV curve of each module and each submodule at every time step. The collection of IV curves is then used to find the total working point, thus determining the electrical mismatch in each group of parallel strings. In this example, we have ground-mounted modules in several orientations, as well as roof-mounted modules. In the 3D scene, we see inter-row shadings as well as shadings from trees and chimney on the roof. The PV DC array defined in the system window must match the 3D scene, and the characteristics of the PV modules must be properly defined in the module's pan file. To use the module layout mode in the simulation, choose the option named Detailed Electrical Calculation according to module layout. Running a simulation with this level of details can take considerable time. For this reason, PVsyst will display an error for system larger than 5 MW peak. If needed, you can adjust these limits in the advanced parameters to allow simulation with larger installed capacities. In the module layout window, you will find a 2D top-down representation of the modules in your scene. In the drop-down list, you can switch between the different orientations. You can open the 3D scene to get a better overview of the system. First, you have to define the mechanical or spatial arrangement of modules on the tables. The number of PV modules should correspond to the number of modules defined in the subarray for each orientation. When defining your field in the 3D scene, you are advised to use the option by modules rather than by sensitive area, so that the table sizes are correctly predefined. However, freely defining tables with sufficient room for your modules is also possible. The tables will be resized according to the assigned modules at the output of this tool. In the module arrangement, you can set the modules for the full system, by tables, or by orientation, and specifying the filling procedure to make sure it fits all the modules quickly in the intended way. When all modules are positioned, you get access to the Electrical Definition tab. On the left panel, you have a list of all inverters or MPPT inputs, as defined in the subarray in the system window. Each string features a set of boxes that represent PV modules, which are then filled with corresponding colors once assigned. On the table's drawings, each module can be assigned to a string, and it will also be painted in the corresponding string's color. PVsyst provides a wide range of rules for distributing strings according to the different strategies, which can be applied to the selected tables or to a specific orientation. If the resulting distribution does not fully meet your requirements, it can be cleared or adjusted. You can remove a module from its assigned string by right-clicking on it, and re-attribute modules by marking the given string and placing it in the scene. When all modules are assigned, you are all set to run the simulation. This will be confirmed by PVsyst in the information panel on the top right of the window. However, finishing the parameterization also gives access to the pedagogical tool, which shows an animation of the shading on your system under clear sky conditions. To access this tool, choose a date and click on Calculate. Right-clicking on a partially shaded module will show how the IV curves of the submodule within the selected module will combine. The dotted curve corresponds to the IV curve if the module is not shaded. The solid lines in different colors are the IV curves of each submodule, whereas the thick green line is the resulting IV curve and the actual PMPP for the selected module. To simulate electrical shading losses, PVsyst first combines the IV curves of all the submodules in a string. It then brings together the outputs of all the strings connected in parallel to get the overall IV curve as seen by the MPPT. From this, the MPPT finds a voltage and current pair that delivers the maximum power under given shading conditions. This is called the maximum power point of the IV curve. Once other constraints are applied, such as inverter limitations, the IV curve will also be used to find the effective operating point. In this window, you can see the combined IV or PV curve for the full system and each inverter. The panel on the left moreover shows the different loss factors for a given time and shading situation. Note again that the weather is assumed to be clear sky day when visualizing results in this tool. When running the simulation, PVsyst takes the weather data and all the other system parameters into account, and the electrical losses calculated with the detailed module method are included in the overall losses reported in the simulation results. Don't hesitate to consult the full PVsyst manual. You can also watch our previous videos.